Everyone, we will solve this today's LeetCode problem. This is LeetCode easy one. Here, evaluate Boolean binary tree is given. So here we need to find given here we have given the root of a full binary tree with the following properties. Leaf nodes have either the value 0 or 1, where 0 represents false and 1 represents true. So non-leaf nodes have either the value 2 or 3, where 2 represents the Boolean odd and 3 and represents the Boolean and. The evaluation of a node as follows. If the node is a leaf node, the evaluation is value of the node that is true or false. Okay. Otherwise, evaluates the node's two children and apply the Boolean operation of its value with the children's evaluations. Return the Boolean result of evaluating the root node. Okay. So it's a very easy question. Okay. So what it's saying that if it is a leaf node, then its value will be either 0 or 1, right? So and 0 represents false and this one represents true, right? So that's 0 represents false, 1 represents true. There is also given 2 or 3. So if there is a non-leaf node, and for non-leaf node, for non-leaf node, there can be two values. There can be two values, either 2 or 3. So 2 represents odd here, and 3 represents and here, right? So this is the whole question which is given, right? And what we need to find, we need to find we need to mainly do these operations like this. We need to go to till this child, this true false 0 and 1, and do this operation based on its parent value. If you see in this example here, this false and this true will be evaluated on the basis of its parent value. So its parent value is and, it means its parent value is 3 here. So it's will be operated on and basis. So false and true becomes false. So this parent will become false. Now this true and this false will evaluated on the basis of this parent's value. So this true and false will evaluated on odd basis. So dot that becomes true. So we have a single node left. So answer is true here, right? So if you have solved if you have solved uh, any recursive any tree problem any tree problem, then this will be an easy problem, right? Then this is an surely easy for you. I suggest you to try this. I suggest you to first try this try this by your own, and then comes to video, right? So if I start from this graph only, so how we will traverse on this, right? So this is given 2, this is given 1, again this is given 1. Now this is evaluated as this is evaluated at 3, and now it's children's, right? Now it's children's. So how this be evaluated? So in this case, this here it is given 0 and this is given 1. This is given 1. So this represents or, this represents and this represents false, this is represents true. So this will be evaluated on the basis of this. So what we will do, we will move from parent till I don't get any leaf node. I don't get any leaf node. So if I got a leaf node, it means either it is a false or a true, right? If I get a leaf node, either it can be possible that it is a leaf node or it is a uh, so it is a leaf node. So we will so it can be 0 or 1, right? So when we go to this leaf node, this 0 and this 1 will be evaluated firstly. Now this 0 and 1 will evaluate on the basis of this 3, right? So for that, what it becomes now? It becomes false. 0 and 1 becomes false on the basis of AND. So this simply simplifies to this again. Just a minute. This 2, okay, something, okay, and this is 1, right? So I iterate till leaf node and then evaluate both on the basis of this parent. So what we need to check, that I will move to its left and right both of the its parents value both. I move to 2. I go in 1 and 3 directions, right? After this one, this is a root value. This is a leaf node value. So I will return 1 to this root 2. I will return this 1 to this 2, and from here this is not a leaf node, so I will it again move to its left and right children, and this is a leaf node, this is also a leaf node. So I will return this 0 to this, 1 to this, and operate on the basis of 3. So 0 1 will give me 0, this will give me 0, right? Right. Now this 1 has already been written here too. Now this 0 will also return here too, because now this becomes leaf node. So this 0 1 will operate on the basis of this 2, which will become 1 ultimately. So this is the answer. That's a simple post order traversal, right? That is a simple post order traversal. So this is a simple post order traversal. Simple post order traversal, right? If you haven't read it about this post order traversal or pre order traversal, sorry, this is a pre order traversal, not post order traversal. My bad. This is a pre order traversal. Sorry, this is not a post order traversal. This is a pre order traversal. So if you have not read this pre order traversal or post order traversal, label order traversal, you should study these first, right? Because these are the basics of this tree problems, right? And this is very easy problem. So you must have solved it, right? So if you not, just read this and then solve this question, right? So let's see how we will evaluate this. So first thing is here, that what we need to do, we need to move in both left and right, right? So we will move in left and right. So what we need to do, we will move in left to right. So, and whenever we are getting to leaf node, we are returning that value, so we will return that value. So first thing is that I when we have a leaf node, when we have a leaf node, so okay, let's write this up steps also. When we have a leaf node, we will return its value, right? The first thing is here. So if I got a leaf node, I will return value, right? Okay. So and now, now what I need to do, I need to also check if it is not a leaf node, then it will be mustard 2 or 3. So if my root value is 2, if my root value is 2, so 2 represents odd value, 2 represents odd. So if 2 represents odd, then, so, and if it is not a leaf node, and if it is not a leaf node, it must be either 2 or 3. So if node value node value is 2, then we need to call its left and right child, and take odd of both of the both of this, both of uh, his child, both of his child, right? Child values, right? And if it is, and if it is 3, then we will take and of both of his, and of both of his child value. This is the simple approach. This should be capital O, right? So if root value is 2, then we will call this solve root left, and we will take odd because this is 2, and we will also call this root right. See, in recursion we assume that this function will give me an answer, right? If you imagine that how will this recursive function goes, we will just assume that this will give me answer, because we believe that this will give me answer because we have analyzed this separate test case, right? We have already given, so we assume that this will give me a correct answer, this will give me an answer, and we will operate on this, right? We don't think that what will happen after this going and this going. We we assume that this will give me an answer and I will operate on that answer, right? This is how we will solve the questions. And if it is not a 2, then we will simply return and voila function, because that will be ultimately and, because there are only two values possible. So we will take and of both of the childs simply, right? Here we have given that the node values can be 0 to 3, and it has either 0 or 2 children, right? So here that will be, there will be no any case that root left, the root will be uh, null. But still I, for the interview purpose, I write this because it's necessary to write this. So you should also always write this, right? You should always write this in interviews, that if root value should be null, then what we need to do. In this case, it should be have either two children or there is no children, so either it is a leaf node or either it has a two children, right? So but in interviews, you should specify the conditions, right? So if there is no root possible, so that means nothing can be handled. So either you return 0 or you can return 1, there is no any issue, because it will never be hit, right? So either you write this or not write this, there is no necessity, right? So this is how we solve the question. Let's run this and try this. uh, okay, this should be evaluate tree. Function name should be evaluate tree. Let's run this again. Now let's see whether I have left any commas or semicolons or what. Okay, this sample test is passed. Let's submit it. This will be passed surely. Yeah, we have successfully passed this. So this is very simple problem. Let's analyze the time and the space complexity. So time complexity will be O of n. Why? Because I need to move for each and every node in this tree, right? We are moving in each and every node by going left and right to each and every tree, so that will be O of n. And the space complexity will be, so we are not taking any extra space, auxiliary extra space, right? So there are two spaces, auxiliary and recursive recursive space. So we have not taken any extra space, so that will be O of n. But there are, that is O of n is recursive steps space, right? Because we are moving recursion stack space, there will be, because we are going again for each and every value to call this function, right? So that will be O of n in the worst case. So again that will be totally of O of n. So this is what, this is the time and the space complexity for this. So this is a DFS approach, right? So this is the DFS approach finally. Hope you have solved this. If not, no worries. Watch the video, understand this, and solve the problems. Okay, bye bye. Have a nice day.